So we are going to continue on in our conversation about the distance formula and the midpoint formula. So the distance between two ordered pairs, let's say x1, y1 and x2, y2 on a coordinate plane is given by, and we have the distance formula, which involves a radical. We subtract the x coordinates, square them, add it to, subtract the y coordinates and square them, and then we're going to simplify. So with the distance formula, I'm just going to draw a quick coordinate plane and plot 2 points. What we're doing is we're finding the length of this line. Okay, so that's what the distance formula is given to us. Your final answer here will either be a radical, an exact form, or a number. Okay, so let's practice. Find the distance between the pair of points, give an exact answer, and where appropriate, an approximation to 3 decimal places. So again, we're finding the length of the line drawn between these 2 points. Okay, so I'm going to call this x1, y1. You could label it the other way around. We'll get the same answer. Okay, so my distance formula is given by my square root. X2 minus x1 is 5 minus negative 3. Now the reason it's minus and negative is there's subtraction in the formula, and the 3 is negative. Okay, add it to, and then we're going to do 2 minus 0 squared. And so now we simplify. Okay, so I'm going to do the subtraction first. 5 minus negative 3 means 5 plus 3. So that gives me 8 squared. 2 minus 0 is just 2. So that gives me 2 squared. And then we'll keep simplifying from here. Okay. So what we have is 8 squared is 64. And 2 squared is 4. So now we're looking at, let me erase this a little bit, the square root of 68. And now what we need to do is we need to simplify this and give an exact answer. So the square root of 68, you can do that in one of the ways that we discussed before. I'm going to use prime factorization for this one. So 68 breaks down. Since it's even, we know 2 goes into 68. We have 2 and 17. Here's my pair. So this is 2 square root of 17 as an exact answer. And then as a decimal to 3 places, I'm getting 8.2462. I'm rounding the 6. There's a 2 next door. Since it's less than 5, the 6 stays the same. 8.246. Okay, so that would be the length. Next, find the distance between the pair of points, give an exact answer, and where appropriate, an approximation to 3 decimal places. So in this case, we have the ordered pairs listed. So my distance is going to be, I subtract the x, so 2 minus negative 4 squared plus 5 minus negative 3 squared. Okay, and as you're doing these, make sure you're looking at your distance formula. It would take up a lot of space for me to have it on each slide. And then we simplify. 2 minus negative 4 is positive 6. 5 minus 3 is positive 8. And then we square that. So 6 squared is 36. 8 squared is 64. And 36 plus 64 is 100. Now the square root of 100, this is a perfect square. It's equal to 10. Now it's just equal to 10. There's no square root there. There's no radical. That's because 100 is a perfect square. Next, find the distance. Same thing we've been doing, give an exact answer, and where appropriate, an approximation. So the previous one, we don't have to give an approximation to 3 decimal places because it's a perfect square. Okay, we're going to keep going with our distance formula. Distance is equal to 0 minus negative 9 squared plus 7 minus 1 squared. 0 minus 9 means positive 9 squared. 7 minus 1 is 6 squared. So we have the square root of 81 plus 36. If we add this together, this is the square root of 117. Okay, so from here, you can use prime factorization or you can find perfect square factors for this one. If we use prime factorization, okay, you can tell if a number is divisible by 3 by adding up the digits. And if the sum of the digits is a number divisible by 3, then the whole number is divisible by 3. So 1 plus 1 plus 7 is 9. So 1/17 is divisible by 3. So 3 and 39. 39 is also divisible by 3. Okay, so I have my matching pair here. So this becomes 3 radical 13, or 3 times the square root of 13. And then we need to give an exact answer as well. So in the calculator, 10.81665, so on. We're rounding the third decimal, or we're rounding to 3 decimal places. So we're rounding this 6. Next to the 6 is a 6. So since this is 5 or greater, we're going to add 1. It's going to cause it to round up to give us 10.18817. Okay. So next, let's talk about the midpoint formula. So the midpoint, which is an ordered pair or a coordinate between two ordered pairs, x1, y1, and x2, y2, that form a line segment is given by, and then basically you're adding the two x coordinates divided by 2, adding the two y coordinates divided by 2. The midpoint is halfway, so this is like taking the average. And your answer, your final answer here should be an ordered pair. Okay, so find the midpoint of the segment given below. So if I draw this segment, the midpoint you can see is actually right here. Okay, it's at 1, 1, but let's prove it. Not all of them are this nice. Okay, so I add up my two x coordinates, so my midpoint is given by -3 plus 5 divided by 2, and 0 plus 2 divided by 2, and then we simplify. -3 plus 5 is 2 divided by 2. 0 plus 2 is 2 divided by 2. So my midpoint here is 1, 1. When you're writing coordinates or typing them, you have to put parentheses there to note that they're coordinates. So the midpoint is not 1, the midpoint is not 1, 1, the midpoint is ordered pair 1, 1. Okay, example 2, find the midpoint of the segment with the given endpoint. So we're going to do the same thing here by using the midpoint formula. Make sure you have that with you. Okay, so -2 plus 1 divided by 2, -2 plus 8, divide that by 2. So we have -1/2. This becomes 6 over 2. And I'm just doing maybe 1 or 2 steps at a time. Our final answer here is -1/2, 3, and it's okay to have fractions in your answer. Okay, looking at part B, my midpoint, again, 3.7 plus 5.4. So I'm adding my x coordinates together and divided by 2. And then I'm going to add my y coordinates together and divide by 2. And for this one, I'm going to use a calculator. So 3.7 plus 5.4. Be very careful. Hit equals and then divide by 2. Okay, your calculator only knows what you tell it to do. Let me write this down real quick. 4.55. Okay, so if you did 3.7 plus 5.4 divided by 2, you would get 6.4. Okay, and what that's doing is that is only dividing the 5.4 by 2, not the entire thing. So either you need to put this in parentheses and then divide by 2, or do 3.7 plus 5.4, hit equals, and then divide that by 2, because that's what's happening. You're dividing that entire sum by 2. Okay, just some help with the calculator there. And so I'm doing the same thing for the y coordinate of the midpoint, -5.4 plus -3.7 divided by 2. And this is -4.55. So this is my final answer here. Next, we get to an application problem. So the graph depicts the growth and cost using a line segment. So it's important it's a line segment. That's what we've been using to find distance and midpoint. Use the midpoint formula to approximate the cost during the year 2010. Okay, so here's 2010. And so I need to get my two coordinates. This is the x-axis and this is the y-axis. So the first coordinate is the year. And the second is the cost. Okay, x, y, year, cost. Same thing for the second endpoint. Okay, so now I'm going to use my midpoint formula to determine the cost during the year 2010. So my 2 years are 2002 plus 2018 divided by 2. And my cost is 79 plus 224 divided by 2. Okay, and so 2002 plus 2018 divided by 2. I'm getting a year here, which makes sense because the x-axis is about years. 79 plus 224, and we're going to divide that by 2. and I'm getting 151.50. Okay, remember this is the year and this is the cost. So to answer this question, the approximate cost during the year 2010 was $151.50. Okay. If you have any questions, feel free to reach out to me.